A by bottom A.
Well, what is it saying to multiply?
It said,
What's it saying to do? What's it saying to do to these?
Subtract.
Well, divide,
Subtraction.
which means you subtract powers. Okay. So here I could just write this as A 1/3 minus 3/5 times B 4 minus third. So I've taken this problem and I've made it into just a get an LCD problem, right? Using the property of exponents that never changes. So whereas before I could have a problem like this, remember the old days when I had a problem like that?
you could just cancel.
And it was pretty straightforward.
Cancel.
Well, here both A's cancel. I didn't really need to do that, but oh well. 3 minus 3 is 0. There's no more A's. Here, how many B's are left alive?
3 on the bottom.
Minus
3 on the bottom. Why is that easier? Because it's freaking whole numbers. The property is the same. It's just that what I'm applying the property to are whole numbers. Of course, it's going to be quicker. Here, I've got, oh crap, it's going to be one extra step to deal with the fractions, but still the same property. I still subtract.
So you gotta do LCD on that?
Got to do LCD here, LCD there, right?
Yes.
And that really right there should be like, oh, okay, cool. That's fine. Not a problem. Right here it would be 15, so it would be 5 fifteenths and 9 fifteenths. 5 minus 9. Negative 4 fifteenths, right? This will be what?
3
So
thirds.
12 thirds minus 1/3 is 11 thirds. And what should these A's do?
Those A's are going to flip.
They should go down.
No.
So to B to the 11 thirds over A to the 4 fifteenths.
Yes.
Because it was a negative power, those should flip,
That was it.
right?
72.
So a lot of times you guys get yourselves in trouble because you're trying to do too much at once, you're trying to get right to the answer, and you're not letting yourself see the progression. Right? I've taken this ugly rational expression radical problem and made it into a get the LCD problem. Awesome. By just applying a property.
84.
76, please.
No, no.
Alright. So I'm going to do something like it. I've had enough of doing all the problems. We're going to do a problem like these. Oh, sorry. So I heard 76 in the mix there, right?
Yes, please.
Doesn't
Yeah,
matter.
I just noticed now that you mentioned it, but I don't know what happened to my paper. I have to fill it in.
Is most important.
Alright, there's one like 76, I think, whatever it was. This is actually a very crazy, easy problem.
Multiply both by 21.
Because what's the property here?
So
Multiply.
The one I have, it has a negative power inside.
Oh, okay. Alright. So what's the property?
Push them by this one.
Not a big deal.
76.
What's the matter? So what happens here?
You're going to multiply it by 21
4
over
7 times 21
Over 1.
over y to the 12, 21
Times
times
21
21.
over 1.
Right? You guys see that?
Okay.
So these cancel. That's nice.
So you're going to have
What happens up here?
84 over.
7 goes into 21.
So you just
Oh, that's
have
right.
the negative sign, that's all.
Well, I'm going to worry about the negative at the end.
Okay.
Sure.
So negative 12.
And now what's it say to do that?
Goes down.
Down.
24.
So
1 over.
1 over x12, y12.
Okay, I don't know why in my mind
You
I
could
thought
take
I
the
had
negative
to
down
flip
first.
it
There's
and
nothing, you could do
something.
this. You can take the negative down first. And then you just do everything we just did. So now you're going to have x to the 4 sevenths
okay.
times 21. Right, you just bring that in.
Okay.
What's 1 to the 21st power? 1. 1 to any power is 1.
Okay.
Because 1 times 1 times 1 times 1.
I don't know why I couldn't think.
Okay, alright.
Maybe.
Now here's the last one. 84.
What is it? 84. It's required.
Oh, so I think let me refer you back to. Did I do that here? Oh, it doesn't matter. I'll show you. C H. Okay. So you have this cube. Is that one that I assigned? CD,
Yeah, 84, 384, E30.
blah, 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 blah. And the length of each side is 1 inch, so it's 1 inch by 1 inch by 1 inch. So they want me to find the length of this diagonal here from C to H. And it's really, if I just look at the bottom, if I pick this up and just look at the bottom, wouldn't it look like this then? C, D, H, and I forget what else over there. G. I just pick up this cube, look at the bottom. There it is. And they want me to find this. Wow, that's really bad, John. Whoop. And this is 1, this is 1. What kind of triangle is this? Right triangle, because these are all squares. Right? So what's true about a right triangle? Sides.
180. No.
Angles add to 180. What do the sides do?
So A.
How do they relate?
A plus B squared.
A squared plus B squared equals C squared.
Okay.
And C is what you don't know. Now just to extend that idea, here's the cool thing. The next thing they ask you is, what's the diagonal CF? Now do you see how that's going through the cube? Probably can't see it on my picture too well, but it's not just on one face, it's actually through the freaking cube. Right? Here's the nice thing. Let me see if I can get you guys to understand. If the cube is sitting here, isn't C to F going to be like this?
Yeah.
You guys see it's going to come up and go from C up to F. So it's like that.
We have C.
So here's a really cool thing. For a triangle, A squared plus B squared equals C squared. Now, 3 dimensions is not the easiest thing in the world, so let me see if I can make it. Well, screw it. It's not very good. If I want to go from here to there, I don't just have one triangle, I have this thing going through a cube. I actually have 1, 2, 3 sides then, like A, B, C. And the really cool thing is A squared plus B squared plus C squared equals, I'll call this D, D squared. You can just extend it. In 2 dimensions, I have 2 sides and this guy going, connecting, right? In 3 dimensions, I have 3 sides and this guy connecting. I just keep going. I'm going to leave that one alone because I'm going to let you guys work on that. That's one that I'm not overly worried about. That kind
You
of takes.
keep going. Can I go to E and all that?
Well, the hard thing is once you get to 4 dimensions, I can't draw 4 dimensions.
All right.
It's very hard to even imagine 4 dimensions. It's basically impossible for us. But yes, you could just do A squared, B squared, C squared, D squared equals E squared.
But you have C.
Not in
C
2
is-
dimensions. C is going to be this.
C is the base of the.
Sure. Well, C is this diagonal here,
Yes.
right?
And the
Now, in this picture, if you don't
one
like me calling that C, I can call it E. It's something different. It's this side here, right? Yeah, it's that side. Okay. Now that one I'm just going to leave alone, because that one, if that's the only one you have trouble with in that problem, you can turn that name homework and I'm happy, because that's a bit beyond. Just leave that one alone. I got to get to the stuff that really matters here.
Excuse me. I cannot explain this.
Okay, what's up, Smith?
It's like this.
Yeah, you can make that big triangle in the middle.
This is 1, and this is 1, and you have the base. Another triangle.
No, this isn't one though. This is whatever you find this to be.
Yes.
Sure.
So it is 1.
Great. You could do it that way. This is a more direct way to do it, but you can also do it that
I
way.
can do it.
Sure, sure. Okay. All right. So, I think you guys remember 7.2 is never in our curriculum.
7-3.
And just to let you know, there will be a quiz on Wednesday,
Today? No, I'm kidding.
5.5 through chapter 6.
Any
Oh,
workshops?
not 7? Okay.
Next one.
There are 2 radical expression workshops coming up next week. As soon as I get rooms set, I'll be emailing it out.
Are you hosting?
What?
Are you hosting?
I might be doing one of them, I don't know yet.
This is next Wednesday.
Next week.
No, next Wednesday.
Oh, this is next Wednesday.
Tomorrow. Next week.
Wait, is it 5.5 through all of chapter?
Today is Wednesday.
Yeah, today is Wednesday.
Right, good. So it
It's
must be
5
next
it's
week.
5.5 to chapter 6 or all of chapter 6?
Yes, all through chapter 6. Yeah, 5 through chapter 6. I'm going to end up doing things a little out of order to make more sense, to tell you honestly. I'll try to tell you where I am at each point. I'm not going to leave us hanging. I'm going to end up today at a good spot where you're not leaving out parts of a section. But to me, I really don't like the way the book ordered this. And that just happens. Let me ask you guys what you think about this here.
We are 7-3 now?
I'm going to do 7-4 because I want to.
So we're skipping 7-3?
For the moment. All right.
Fine.
The 7-4 comes naturally from what we've already done. 7-5, doing that first makes 7-3 make more sense. So that's what I'm going to do. Okay? So 7-4, what I mean by it just comes naturally from what we just did, because we actually had a discussion a minute ago that relates to exactly this. What do you think that is? 5 what's?
5.
5's the
I don't have any 5s up there.
5 is
I have 2 radical 5s plus 3 radical 5s makes 5.
Radical 5.
So now look at this. Here's the cool thing. What is square root of 5? Can somebody tell me what is square root of 5? Tell me exactly what it is.
It's a fraction.
No, that's 5 halves.
To the power of 2.
You can't. Let me just cut that short. Right? Square root of 5 is something above 2. It's 2 point something or other, but you can't do it. So isn't it like a variable? 2 of these plus 3 of these. 2 of these things I don't know plus 3 of these things I don't know makes 5 of these freaking things I don't know. Right? So it's exactly what you would hope it would be. It only makes sense. So this is the idea we were talking about earlier about like terms. If they're like terms, I can combine them. Right? In fact, we did this earlier today. So a lot of this homework is going to be already like terms. Some of it, of course, is going to be they're not quite like terms yet. But right now, I just want to focus on the ones that are like terms. So if I had this here,
What do you think about the first one?
5, yeah. 5 plus, yeah.
because of course these, can you do anything with them?
No.
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 Cool. And please, dear God, don't come in all of a sudden and go, well, let me just square both of them. You can't just square this out of nowhere, right? Only if you had another side, maybe you could square it. Don't try to square it to kill that square root. This is it. That's all you can do. You put your like terms together, you're done. Just like any time before we had variables. Now I'm trying to tell you, this isn't a variable. It is the square root of 5, but I don't know what the value is. So the really cool thing is they act like variables would. I'm just collecting them because I don't know what the hell they are. I got 2 of them there, 3 of them there. Okay, I got 5 of these weird things. Great, right? So the idea is pretty straightforward. It's like terms. Okay, so that's a little snippet of that section 7.4. Now, so obviously that's addition and subtraction. Those are pretty straightforward as long as they're like terms. If they're not like terms, either I can't do something or I need to learn how to simplify it. And that's what we're approaching, is how to make like terms when they're not like terms. What do you think, what's your gut tell you, and this is just to let you know is 7.5. So please, dear God, don't freak out that I'm doing pieces of things. It all is going to come at you eventually. What does your gut tell you this might be?
14 squared?
I think you're right, but just be careful how you say it. It's not squared.
Square root of 14.
Square root of 14, right?
I like the way you say it.
Now, over here, I'm glad nobody tried to tell me this was somehow 25. Why can't you multiply that 5 by that 5?
No.
Because this isn't a root, right? As long, okay, this sounds like it might be a note, because it sounds like I'm going to start talking slow. As long as they're the same root, you can multiply them and divide them, right? And here's the reason. You ready? Here's the reason. Let me see it. And you're not going to have to do what I'm about to do, but this is the reason why this works. The reason with a weird R. 2 to the 1/2, is that cool? Square root of 2 is 2 to the 1/2?
Mhm.
And square root of 7, of course, is 7 to the